universal messaging is based on your technology, it's Java based, and so this is going to actually help you move forward, so we can actually address today's situation, migrate you up to universal messaging, and then you're good to go forward. There's 2 years to go, end of maintenance at the end of next year, October, end of support in October 2020. So one of the things you could also do is look at your architecture. Integration server can connect to more than one universal messaging server, which you can't do with Broker. Active-active clustering is fairly unique to universal messaging. There aren't many other products that do it, well, I don't think there are any other products that do it in quite the same way. Happy to wax lyrical about that if anybody wants to catch me after the presentation. It's a very long discussion, and yes, a cure for insomnia. 90-day free trial. You do need to be aware that you're not supported by our support people whilst you're trialling it, but you know, frankly, if you phone Andrew, I'm sure that he'll actually he'll find somebody to help you.
I'll definitely edit that out of the video.
So you know, I'm very keen that people actually need to migrate now have a smooth and easy ride of it. Right, any other questions? Yes.
So we are actually in the process, we are trying to integrate with our CI/CD pipeline, the universal messaging components, and face a lot of roadblocks. Can you elaborate on what is the timeline of the DevOps and what is targeted in that, like improvements in the DevOps area?
Okay, so in the DevOps area, we're working on obviously in enabling Command Central. Each release, we actually increase the capability that we're actually making available in Command Central. Can I get with you after this and get your email address? I've got a table, and if anybody else is interested in giving me feedback, I've got a table of capability that's not yet in Command Central. I'm gathering information on how to prioritise that. You can give me some of that priority, and it will tell you what we've actually already got as well. Okay, I better hand over to Manish, because otherwise...
Hi everyone, my name is Manish Tekan. I'm based in Washington DC, and I run the products for data and analytics at Software AG. We have a lot of customers using our data analytics product. You're building an application and you have a system of record in the back, and you want to have an in-memory data grid in between so that you can store the data as close to the application. So a lot of our use cases are around low latency data access. At least in the last 3 years, we have seen people move their entire operational data set into in-memory. Initially, we used to see that they would front Terracotta in-memory solution with their database, so the database would be at the back, a display database like Oracle and the like, and then they would put Terracotta in between. But now we are seeing that they actually want to store the entire operational set in memory. We have multi-terabyte customers who actually store the entire data set in memory. But this pattern we saw with big memory, where a lot of our customers started to actually reduce the reliance on the database by actually pinning the data so that the caching platform does not evict data. So they're basically using cache as actually a store. And that was the reason why we, about 2 years back, started to rethink the storage tier of Terracotta. We introduced Terracotta DB, a data store last year. And what that basically gives you is a unique thing that, not only can you start, caching data like we do today, but actually store your entire data set in memory and use the same store not only for just operational storage, but also analytical processing. Because we saw that a lot of the customers' use cases where they would start storing their operational data in big memory, and then they would want to run search on top of it. And so initially we used to have like this, let's say these are the keys, and the value would be a big block or a byte array, right? That's Java object, C type object, right? But now when you start putting data in Terracotta DB, you have an option. You can still do the byte array like you're doing today, but you have an option of saying, okay, for this key, I need to put what we call a cell. Cell is kind of like a column, but it's not like a relational database. It's more like a NoSQL database, where you can have one row with only 3 columns and second one with only 2, like a NoSQL database. This is basically a non-relational storage tier, so that you have flexibility. Like today, if you have a use case where, let's say your data, you need to store name, age, and gender, and tomorrow you need to start storing height as well, you don't need to change the schema, so schema-less. Right? That's the kind of the model we have followed. So this kind of gives you an idea on, we have hash-based index, and then you can optionally say, you can put a secondary index on it. So let's say, in your use case, you want to say, okay, give me everybody with age greater than 40, right? Currently in big memory, the platform would need to deserialize all the objects, look inside and look for the age. But here, if you put a secondary index on age, you can go through the entire index very quickly. And you might want to say there are so many NoSQL stores out there, what's the big deal about DB, right? What we have learned from our use cases, and as I said, we have some very large customers storing data in memory. First of all, we're kind of born in memory, right? We know that's where we started from because we are a caching platform, and now we have become an in-memory database. Whereas the other solution, while they have started with a disk-based system, and they're putting in-memory options. So we are really coming from different angles. Now, because we are basically a Java platform, we wanted to leverage Java Extremes, which gives an ability to do things like predicate pushdown. So let's say this is a code sample here. It says, okay, give me all the person records. So if you're writing in Java, you say person.record, and give me the record where the age is greater than 55, and give me the value of their first name, and return me a list. So what we are able to do is, we actually understand this is greater. That's the function we understand. So there are some pre-built functions which you get in DB, which the platform understands how to break it down and push it down to the server side. So this particular query, we can basically do a predicate push down and push the search compute onto where the data lives. Right? So if there are 3 node cluster, and this could be a very large cluster, it could be a 50 node cluster, and then your data set is broken down into different shards. So we are able to push that compute down on the server side and then collect it on the client. So that basically optimizes search, especially if you're searching in large data sets. And the interesting thing also is that, just imagine we actually have a customer who's storing about I think they're up to 8 terabytes of data, and all they want to do is they want to say that, okay, for customers living in Melbourne who have visited or made this purchase, increase their threat score by 1. In a typical database, you would actually do an update query, right? Whereas in our case, we can actually write a compute function, and it can push that compute down to all the server nodes, and the compute can happen where exactly the data lives, so you don't have to move data around. And that's a huge optimization, which that kind of large data set gets. A lot of people here are from webMethods. They use the webMethods integration platform. So last year when we released DB, we made sure that we wanted to make this great product available to the webMethods customers. And when we released in October last year, we actually provided a bridge. We had to, because a lot of the webMethods customers are used to the adapters and building flow services. So there is a programming model which is specific for webMethods customers. So when you buy this adapter, you can actually do create, read, update, delete. You can connect to a live DB cluster, and in your flow service or services you're writing in webMethods, you can use this adapter to do basic web functions, start storing your data. This is the first version which is out. Actually, it's a small font, but you can see that how you can, in the admin console, how you can do connection management for DB, how you can start creating data sets and things like that. This is a designer. So if you have the adapter, it's going to give you a nice space, the same programming model you're used to actually, create data, read data. Not everything is available yet, but we are going to release another version shortly of the adapter, and you'll also get search availability now. Mashphone now directly can connect to a running Terraform DB cluster, and in fact you can build dashboards on the same database. In fact, if you see here, I can do select star, so I can do SQL. So we actually have a SQL select only for now capability on top of Terraform DB. So it lets you do some basic functions, especially for ad hoc querying is a great tool. But right now we don't recommend you doing all your queries in SQL, because fundamentally it's there's an impedance mismatch between SQL and no SQL storage here. So this is a very convenience if you're building something, and it basically shows you the power of having an operational data store and being able to run analytics on it. A lot of time, in fact, we visited a customer last week, and they said, the last thing you want to do in a distributed data storage tier is to move data around. The day of ETLing into another database and then running your BI on it, that's error prone, right? So what if I can basically use the same database where my operational stuff is running, and I can do some basic search and analytics on it. And this kind of shows you that, and that's what we want to do. We want to give our web methods customers who are looking for these new style of scale-out databases to have one unified platform where they can do caching as well as storage and analytics on it, right? So you have complete. We are sure that the analytical workloads are definitely moving onto the cloud, but we believe that even the operational applications will eventually move to the cloud. That's a trend we are seeing. So we want to make sure that the reason why we are supporting Docker and Kubernetes is because then that gives you an ability to decide in a vendor neutral way whether you want to run this distributed data store on your on-premise data center or AWS or Azure tomorrow. So we don't want that document. That's the reason why we're investing in Kubernetes and Docker. So that's a very good thing. I want to leave you with some links. So our community site is terraform.org. As I said, we actually are a lot of our projects are open source. In fact, we are also planning to open source the DC store, the new stuff, in the recent future. And as I said, if you go to Docker store, just search for Terraform DB. That's a good place to download the image, play around, and then there is a link there. Quick questions?
I had a couple. First one, just interesting, saying people are using this for sort of record sort of situations. Is it possible to have some like a high availability situation? Like if you've got say nodes that start failing, is there sort of recovery built into the product?
Yeah, absolutely. So the picture I showed you of the TSA, the Terraform cluster. Each node in the cluster, typically our customer run active and mirror nodes. And in fact, some customers run multiple mirror nodes, so active and multiple mirrors. So there is high availability kind of built in, that's supported. There is also, Jane talked about split brain. That's a common thing, right? And you don't want to have that happen. So we have a quorum kind of scheme where it's tunable. In fact, we have customers who run one cluster which spans data centers. So you can imagine, with network partition, bad thing can happen, right? So we have customers. I took a few names. In fact, there's a very funny story. I think one of the big financial banks in New York used Terraform. In fact, there was no downtime for the cluster. They actually forgot which servers were running in the data center, the Terraform software. So it's really that it is the ability to have the cluster highly available and fault tolerance is non-functional for us. That is our key goal, because we are talking about operational data. We can't lose the data. So it is a highly available system.
The other question I had was some of the other features we're used to from relational databases, things like constraints and transactions. Is that available in Terraform DB, those features?
Yeah, so not constraints, but transactions we are going to support in October. Again, transactions is a very loose word, but we want to basically provide what we call transactional boundaries. So things like, I showed you the picture where there were keys and the values. So we can say that in a particular data set, you can actually make that atomic. But we want to, the difference we want to give in this product is that we want the end user to have the flexibility on deciding, either you want consistency or availability or, what. So I think it's a fine balance. But yeah, that's something which we are going to start supporting in October. Especially, I think the use cases came from web methods to have support for transactions. Local transactions is what we are going to support. XA is still under question.